Hi everyone. I had a suggestion from someone that I do a problem for you start to finish. Not just give you the hints, not just give you the answer key, but actually do a problem for you from beginning to end. So I just picked this sunspot problem because I think it's one of the harder ones. I did give you hints on this one, and I also did give you the answer key on this one, but I'm going to just take you through the problem and show you how to do it from beginning to end as well. So it is off of worksheet 3 if you're wondering where I got it. So I'm going to start at the beginning and read it for you. It says, for several hundred years, astronomers have kept track of the number of solar flares or sunspots which occur on the surface of the sun. The number of sunspots counted in a given year varies periodically from a minimum of 10 per year to a maximum of 110 per year. So those are two very important numbers. Between the maximums that occur in the years of 1750 and 1948, there are 18 complete cycles. So there are 18 complete cycles between these years. Well, between those 2 years, we have 198 years. And in 198 years, I have 18 cycles. Well, I want to know how many years there are in one cycle, because that would be my period. So if I take 198 and I divide it by 18, that would tell me that I have one cycle in 11 years. And again, what I did is I took 198 and I divided it by 18, and I got one cycle every 11 years. So 11 is my period. So that answers question A. What is the period of your sunspot cycle? So now let's move this up a little bit. It says, assume that the number of sunspots counted in a year varies sinusoidally. Now we should know by now what that means within the year. Sketch a graph of 2 sunspot cycles starting in 1948. Well, I always just draw one. So I'm going to sketch my X and Y axis. And it says started in 1948. So here's 1948. And the next cycle would start how many years later? Well, we know that one cycle occurs every 11 years. So if I add 11 to 1948, that would be 1959. Remember, 11 years is one cycle. Now, if we go back to what we read before, these cycles, it was 11 years between the maximums. And that happened, or we found that up here, in this right here. Between the maximums. So my maximums were 110. So I'm going to put that up here. My minimums were 10. And again, I got that. That's my underlined data in red. So I can put a dot here and a dot here. Those are my maximums. And now I need to find my minimum. Well, remember, it's all about halves. So my minimum is going to be halfway between these two numbers. Right there. All right, so since the distance between 1948 and 1959 is 11 years, this will be, let's see, 1948, and that would be 1953 and a half. So there's 5.5 years between 1948 and 1953 and a half, and then 5.5 years between 1953 and a half and 1959. Since again, this total distance is 11. So now we go on and we need to find our midline. Remember, the midline is the distance halfway between our max and our min. So halfway between 10 and 110 is 60. That will help us find our amplitude. Our amplitude then is 50. We know our period is 11, which will give us our frequency, 2 pi over 11. What else do we have here? Oh, our phase shift. It started to the right, 1948. And our vertical shift was up 60. All right, so now we should be able to write our equation. Let's sketch the graph here. So my equation will be y equals 50 cosine. My frequency is 2 pi over 11. I have to take consideration my phase shift, so my year minus 1948, parentheses, and then my vertical shift up 60. So that is my equation. Now, how many sunspots would you expect to see this year? Well, you could plug in 2015, take x equals 20, actually we're 2016. Plug that in for x right here and see what you get. And then part E we are not doing because we do not have enough information yet to do that problem. So I hope that helps you with this. Let me know if that does, and I can definitely do another one for you. So have a great day.